Let us proceed now for the energy. Now, for the energy is the ability to do work. Energy. Okay, we have energy. Now, for the energy, ability to do work, types of mechanical energy. Energy can be transferred from one object to another. Work changes the energy content of an object. There is no single measure of energy content of an object because energy can take on different forms. We have kinetic energy. When you say kinetic energy, energy in motion. And moving object has energy by virtue of their motion. The motion is called kinetic energy after the Greek word for moving. The unbalanced force that accelerate the object from rest to its final velocity produces kinetic energy. The amount of kinetic energy an object has depends only on how much mass it has on its velocity. Formula for the kinetic energy, that is equal to 1/2 mv squared, where m is the mass, v is the velocity. Now, for the change in kinetic energy, that is also equal to 1/2 mass times final velocity squared minus initial velocity squared. Okay, where m is the mass, v is the velocity, and then v here is final, v sub o is initial. And delta Ke is the change in kinetic energy. Now, for the potential energy, okay, energy at rest, a massive object elevated some distance above the ground clearly has some energy associated with its height, where the formula for the potential energy is equal to mass times gravity multiplied by the height. And while the change in potential energy is equal to mass times the gravity final position minus the initial position. Okay, what are the units? Okay, we have units. We have Newton, meter, joule, the same unit as the work. Then for the SI, this one is for the SI. For the CGS, we have dyne, centimeter, ergs. Then for the English, again, we have foot pounds, or BTU. Again, 1 BTU is equal to 778 foot pounds. Now, okay, do you still remember the conservation of energy? According to the law, to the conservation of energy, energy is neither created nor destroyed, but it can only be transformed from one form to another. Now, for the conservation of energy. Okay. Energy is neither created nor destroyed. It can only be transformed from one form to another. Okay. Example. A car is moving at 100 kilometers per hour. If the mass of the car is 950 kilograms, what is its kinetic energy. Now we have formula kinetic energy is equal to 1/2 mv squared. Okay, we have 1/2. The mass is 950 kilogram. Okay. Then the given is 100 kilometers per hour. Let us convert first. Okay, 100 kilometers per hour. 1 kilometer is equal to 1,000 meters. And 1 hour is equal to 3,600 seconds. And therefore, the kinetic energy is equal to, okay, this one is squared for the velocity. 366,512.35 joule, or that is also equal to 0.367 megajoule. Another example, number 2. Okay, what is the potential energy in foot-pounds of a 10-pound box that was raised 4.9 meters. Using the formula, potential energy is equal to mass times gravity multiplied by the height, or that is equal to, since we have 10 pounds, therefore this one is now the force, F times H, which is equal to 10 pounds multiplied by 4.9 meters. Convert, 1 meter is equal to 3.28 feet. Cancel meter, we have foot-pounds now. Okay, therefore, potential energy is equal to 160.72 foot-pounds. Number 3, example. A projectile is shot upward from the earth with a speed of 30 meters per second. How high is it when its speed is 12 meters per second? Ignore air friction. Ignore air friction. The formula that we're going to use here is the change in kinetic energy plus change in potential energy is equal to 0. Therefore, we have change in kinetic energy plus change in potential energy equal to 0. We have 1/2 m final squared minus initial squared plus mg h final minus initial equal to 0. We have mg h2 minus h sub equal to negative 1/2 m v squared minus v sub o squared. Mass is cancelled. Therefore, we have H2 minus H sub O. Equal to -1/2 v squared minus v sub o squared over d gravity are equal to negative v squared minus v sub o squared over 2g. And therefore, we have h2 minus h sub o is equal to negative 12 squared minus 12 given is 12 meter per second minus 30 squared over 2 times 9. 2 times 9.8 meter per second squared. Unit meter per second for the velocity. Therefore, 12 meter per second squared minus 30 meter per second squared. Okay, the value is 38.6 meters.